Hello guys, thank you for joining us today. I hope you are enjoying Cisco Live. Before starting with our session, I would like to ask you a couple of questions. How many of you have faced drops before in your devices? It could be a switch or it could be a router. Awesome. Okay, and how many of you knew what was the reason because of those drops? Only one. Okay, so this is a very good session for you because today we will present Cisco iOS XR8000 troubleshooting LPTS drops. My name is Ricardo Ferrer. I am an escalation engineer for the TAC XR team. I have been working on IT and networking for the last 7 years, and I have been working at Cisco for the last couple of years. And with me is my colleague Mario.
Hi everyone, I hope you all are doing well. I'm Mario Sotres. I'm an escalation engineer for HTTS XR team. I have been working at Cisco 4 years, and in those 4 years I've been working with XR technologies. As Ricardo mentioned, this will be a very useful presentation because we know that sometimes might be kind of confusing to know how to troubleshoot drops. Or sometimes we don't even know where we should start looking at that. But today we want to change that. So let's take a look at the agenda for today. We will start with a brief introduction for the Cisco 8000 series routers. And we will also check a little about its architecture. Then we will know what is PUN traffic, what is PUN traffic path, and then we will check what is LPTS, how to troubleshoot LPTS, and last but not least, how to configure LPTS policy rates. So let's go to the first point for today. And let's start saying that these devices are the last generation for XR platforms. And we can find it in 3 different flavors. The first one would be fixed, sometimes called Pixabox. And the second one would be modular. This allows us to insert different line cards in the same chassis. And the third one would be centralized, which is a mix between fixed and modular. As any other service provider router, we are expected to receive and handle thousands and thousands of packets per second. So that's why these are powered by the Silicon One ASICs. And in addition to that, these devices run iOS XR7, which is the last generation for XR code. Now that we know more about this platform, let's know more about its architecture. So for that, I would like to use this diagram and split the explanation in 4 stages. In the first stage, we will have the packet arriving into the router and going to the physical optics. Here, depending on the port number, a specific slice will start processing that packet. Then, the line card MPU will start processing the packet like with .1Q. Depending on the type of the traffic, the RP or line card CPU might need to process that packet as well. So in the case of the line card, the MPU will send the packet to the line card CPU. How? Well, it will send it to the SPP first. Then SPP will send the packet to NetIO for layer 3 traffic or to SPIO for layer 2 traffic. Some protocols that might be processed here are like ARP or NetFlow. In the case the ARP needs to be processed in that packet, the line card MPU will send the packet to ESD. ESD stands for Ethernet Switch Driver. And this is like a mini switch that allows us to connect all the line cards with the RPs. So if the RP needs to process that packet, the MPU will send the packet to ESD, and ESD will forward that packet to the RP CPU. At this point, we know more about this platform and about its architecture. But it's also important to know that all the traffic that will be sent from the line card MPU to the line card and RP CPU will be called PUNT traffic. And Ricardo, can you let us know more details about this PUNT traffic and what is PUNT traffic?
Yes, thank you, Mario. To explain PUNT traffic, I will share with you a couple of examples. The first one is that punted traffic is network traffic that travels from hardware to software for CPU processing. Why is that? Because basically the router needs to analyze the content of the packet and needs to get, for example, the source IP and destination IP. Another example is PON traffic, that is a popular terminology used for sending packets to the control plane for processing, just like BGP packets, OSPF packets, or any other routing protocol packets. And I think that the most common way that we know PON traffic is for us traffic. Now that we know what is PON traffic, I will share with you a diagram that explains all the stages that the PON traffic needs to pass by. Moving forward with the PON traffic path, we will start, as Mario mentioned in the previous slides. It will come first in the ingress MP. When it has been processed, it will go through LPTS, and actually Mario will explain this later. Then it will go through ESD in case the traffic needs to go, for example, from the line card to the RP, because ESD is basically like a switch that interacts, the line card makes the interaction between the line card and the RP. Then it will go through SPP, that is basically a filter for layer 2 or layer 3 traffic. If it's layer 2, it will go through SPIO. If it's layer 3, it will go through NetIO. And finally, it will reach the line card RSP or the line card or the RSP CPU. And as mentioned, Mario will help us with the LPTS explanation.
Thanks, Ricardo. Okay, we have here the concept of LPTS a few times already. But before going further, I would like to do a small comparison. If we remember, with iOS or iOS XE, we have a concept named COPP, that stands for Control Plane Policing. In the case of XR, we don't have the same concept, but instead of that, we are using a powerful tool that is named LPTS. And LPTS stands for Local Packet Transport Services. How it works? Well, LPTS policies and filters the packets based on the defined flow type read in hardware before sending the packet to the software. And another thing that we need to take in mind is that policies work on a per MP basis. What does this mean? Well, it means that all the defined flow type rates will be configured across all the MPs in the same line card. And to explain better how LPTS works, I would like to use this diagram. Here, we will have the router accepting the packet and it will go to the FIB. If the FIB detects the packet is a for us packet, it will be sent to the LPTS IFIB. Here, LPTS will decide if the packet needs to be processed by the RP or the line card CPU. Otherwise, LPTS will be dropping that packet. But how can we know why LPTS is dropping the packet? Well, here Ricardo will start letting us know how to troubleshoot LPTS drops.
Thank you, Mario. Before starting with the troubleshooting LPTS drops, I would like to mention that we are sharing a real scenario that it can happen in your network. Actually, it is a very basic topology. We have just two routers acting as an active and standby for HSRP. And for this scenario, we have the HSRP sessions flapping. Now, starting with the troubleshooting, we will make use of a very powerful tool that are actually enabled in our devices. And what is this tool? The syslog messages. And as you can see, if we check the show logging, we will see, for example, the bundle letter 1.10 having the state from active to speak, and then from speak to standby. And the same for the other sessions. Now that we identify some logs for this specific issue, we need to move forward, we need to investigate further. And actually, we can use the same diagram that I just showed you. If you remember, when the traffic enters to the router and to the interface, then we need to start checking, for example, the ingress MP. The first thing that we need to do is to use the command show interface, and in this case is the bundle letter number 1. If we go further, we can see the first thing that we need to check is how many transitions does this bundle has. As you can see, we have 0 transitions, meaning that the interface is stable, and we have 0 flaps. Another important thing to check is the inputs and outputs drops or errors. And as you can see, we have 0 input errors and 0 output errors, meaning that the interface is stable and actually is forwarding traffic. But this was just like the first step. The next thing that we need to check is the ingress MP. To do that, there is a very useful command. The command is show drops all location null. And actually, for this specific command, I would like to ask you to save the trap ID value. I will show you in the next output. Another important thing to do this troubleshooting is to run the command several times. And if we see the packets drop counter is increasing, then it means that we are still having the issue. But let's see how it looks, the output. If we use, again, the command show drops all location all, we will have a lot of information. The first thing to check is the trap type. As you can see, this is the not my Mac. Then we have the MPU ID, that is basically the MPU where the traffic was received. Then the trap ID, that is the number that we need to save. In this case, is 6. And if we go a little bit further and we check the last column for the packets drop, we can see that these drops are constantly increasing. There is another command that is very useful and actually shows us very similar information, but it will include some extra legends. For example, this command, show controllers MPU stats traps all, instance all, location null. And we will basically have more information about these traps. And as you can see, we have, for example, the same not by MAC trap, we have the same trap ID, and we have the same amount of packets trapped. But if you check right below the command, there is a legend that says traps marked with a D and a star are pointed to the local CPU. And to check this, we can use the show capture packets trap CLI. So now we are going to use the trap ID that I just mentioned. If we use the command show capture packets trap 6 location null, we will be able to check the content of the packets. And for example, if we check the Ethernet payload, we will see that we have the source MAC address, and actually this is the MAC address for HSRP. If you remember, when you configure HSRP, you will have mostly the same MAC address, at least for the beginning. We have 000, then 0C07, then AC, and then another number. Meaning that this traffic is also pointed, and it is related with HSRP. And if you remember the diagram, the first thing to do is to check the ingress MP. Now that we check the ingress MP, then we can go through LPTS, and for that, Mario will help us.
Thanks, Ricardo. Okay, before going further, I would like to do a quick recap about HSRP. Why? Well, because HSRP is a flow type that needs to be processed by the RP CPU. So it's important to check the LPTS rate for that specific flow type. How can we do this? Well, just by using a single command, which is show LPTS PIFIT hardware police location, and as in this case, we will be using the RP as the location. With this command, you will be able to see that all the flow types have their own rate, and this rate is configured in packets per second. In addition to that, with this command, you will be able to see if LPTS is dropping packets for that specific flow type. But it's important to know also that if we are observing drops by LPTS at this point, we don't know if these drops are expected or not. But for that, first let's take a look for the whole output for this show command. Here, if we get focused to the HSRP flow type, we can see that the current rate for that specific flow type is set to 520 packets per second. And if we go to the right, we will see that LPTS is actually dropping packets for this specific flow type. But again, we don't know if these drops are expected. But to know more about this, let's take a look at the configuration for one of those HSRP sessions. If we take a single HSRP session here, we can see that the timers were set to have a hello timer of 300 milliseconds. This is an aggressive timer, right? Well, this means that we are expecting to send at least 3 packets per second on this session. And at this point, everything could be normal, everything seems fine. But what about if we have not just one, but 240 HSRP sessions, and all of them have the same aggressive timers? Well, that might be causing something weird on the router, right? So let's take a look on both devices. Here we can see that one of those routers is facing an issue. Here we can see that the HSRP sessions are flapping and jumping between the active and standby states. So we know that HSRP has an issue right now. And this matches with the behavior that Ricardo was showing us from the syslog. So as a summary of the issue so far, we have 240 HSRP sessions, and all of them have aggressive timers. And as we said previously, we are expecting to send at least 3 packets per session and per second. So if we multiply 240 by 3, we will get around 720 packets per second. And if we remember from the previous output for the show command, this flow type had a rate set to 520 packets per second. So we are exceeding that rate, and we can confirm that those drops are expected. So at this point, we know that we have an issue. We know what is causing that issue, but how can we fix this? Well, if we, based on the configuration guide for HSRP, it says that if we are planning to use a high amount of HSRP sessions, or if we are planning to use aggressive timers here, it's better or is recommended to adjust those rates for at least this flow type. But again, this is not the only option that we have. Instead of using aggressive timers, we can consider another options such as BFD. But going back with the rate for LPTS, how can we really fix this? Well, what about if Ricardo shows us how we can configure or adjust those LPTS rates?
Thank you, Mario. Before starting with the configuration of LPTS polish rates, I would like to share you some indications or some considerations that you need to have when you are configuring this. Why? Because it can have some consequences. We can have two different scenarios. The first one is that if we increase the rate in an aggressive way, it could lead to higher CPU utilization. So if we are playing with all the flows, we can have the CPU increased by, let's say, 4% for one process, 10% for another process, and then it can potentially cause an issue with our routers. The other scenario is that if we decrease the rates, it could cause the router to drop the packets, just like we are doing right now. But it can have the scenario that we will be dropping packets that we actually were expecting. So please have in mind these considerations. And moving forward with the configuration, it is actually very easy to configure. We just need to enter to a configuration mode. Then we need to start with LPTS, PIFIP, hardware police. Then in this case, we need to configure the flow, that is HSRP, and then the rate. Once we have configured this, we just need to type commit, as in all XR commands. And a way to validate the configuration, we can just type show run LPTS, and we will have all this information here. But this is not the only way. We also need to validate that this has been applied. How we can do this is using the same command that Mario already shared with us, the show LPTS PIFIR hardware police location. And as you can see, if we focus on the HSRP flow type, we can see that the current rate has already increased. And actually, the packets are not constantly increasing, meaning that this issue is already fixed. And if we also check the show HSRP summary, we will notice that in the router one, we have all the session in active states. They are not flapping between states. And in the standby router, we will see basically the same. Those sessions are not flapping anymore. And as you can see, this issue has been solved. Another thing that we recommend to do is to use the top command, because it will show us how actually the CPU utilization is happening in the router. And as you can see, for this example, HSRP is only consuming 4%. This may not be big at all. But if you consider that if you are configuring, for example, other protocols or other services, at some point you may see an impact. And actually, something that we would like to share with you is that we would like to ask you to have some activities after this session, and Mario will help us with that.
Thanks you. Okay, we would like to discuss some points with you as a call to action here. The first one would be check your current baseline for LPTS. Why? Well, because it's important to know your network, know your router, and this doesn't mean that you need to adjust or modify anything here. Just check what you have and that's it. The second one would be check what protocols you have on the router. What protocols are you expecting to handle here and how many packets you are expecting to receive at all of them. If this will allow you to consider if LPTS rates needs to be modified or not. Otherwise, just leave it like that. And the third point here will be check your current CPU utilization. Why? Well, because as Ricardo mentioned, if we are modifying or adjusting the LPTS rates here, we are allowing the RPs or line card CPUs to process more packets. So this means that they will have more work to do. Also, we would like to share with you some references if you would like to go further with LPTS configuration and also how to implement HSRP. And finally, we would like to share with you a list of show commands that you would like to use in case you would like to go further for the rest of the PUN traffic path here. Okay, I see that you are taking some pictures. Okay. I don't know if we have time. Okay, it seems that we have just a few minutes for some questions. So tell us, guys, what questions do you have? None? It's because now you are experts, right? We told you we were going to change that. Okay. Oh, if you can help us go into the micro, it will be great to hear everyone here. Sir, I think that we are not hearing.
Sure. How do we troubleshoot the MTU related drops on a Cat 8K?
Okay. The question is can we troubleshoot the MP drops? The
MTU.
MPU
Like
drops.
there are fragmentation happening, and fragmentation drops could be occurring on a Cat 8K. Sorry, Cisco 8K. How do we troubleshoot that?
Okay, for that, there will be another session because it's important to also go deeper to the MPU to know how the MPU is working. Because as Ricardo mentioned, there are some important show outputs that we can get here, like the show drops all ongoing, that can let us know what is the router detecting and how can we isolate the issue. But for that, if you want, we can share more details about that later. Also, if you guys have some other questions, you can visit us at the tag booth and we can share more information about how to troubleshoot it on the 8000 platforms.
Any other question, guys? All clear?
Not yet.
Not yet?
Okay, awesome. Great.
It's because you are an expert.
And in case you would like to check any other sessions that we have already provided for 8000s, you can also scan this. If not, we will be at the tag booth and we will share this information. So if you want to check any other session, you can just scan the code.